Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2020 Maths Methods Exam 2 multiple choice section. So yeah, let's get started. Okay, question 1. Let f and g be functions such that f negative 1 equals 4, f negative 2, so f2 equals 5, g of negative 1 equals 2, g of 2 is that, and g4 is equals 6. The value of g, of f blah blah blah. Okay, so first what I'm going to do is find what f of negative 1 is. So what is f negative 1? Well, if you look, f negative 1 is over here. It's equal to 4. So now rewrite the function. Because now we know that f negative 1 is 4, we're going to put 4 inside the function. So what is g of 4? Well, we know that g of 4 is 6. So your answer should be 6. Nice. Let p of x equal this, where a is an element of all reals, where p is divided by x plus 2, so that's your factor. Okay, it's not a factor actually, it's okay. So it's divided by this, and the remainder is 5. Okay, to do this, what we do is, this over here, we actually let it equal to 0, and we solve. So x plus 2 equals 0. X equals negative 2. So when x is negative 2, your remainder is 5. So we're going to shove that negative 2 inside the function. And it should pull out 5. Your remainder is 5. Now what? Okay, now go to your CAS, and this is what I'm going to do. First, we're going to define the function. So define p of x as x to the power 3 minus 2 times ax squared plus x minus 1. Oops, minus 1. All right, so we know that when p negative 2 should equal 5. Yep, and we want to solve that for a. We get a equals negative 2, so E is your answer. All right, let f dash of x is this, then if f of 6 is then, what's f of x? Okay, so, find the antiderivative. Use your CAS again. So shift plus. And what we want to do is write the function. 2 square root 2x minus 3 dx plus c. Remember, there will be a plus c. So this over here, we want a plus c here. Put a plus c. Now we get this. Now what we want to do is we want to solve this whole equation over here. Given that we know that your x value is 6 and your overall y value is 4, comma c. And we found out that c equals negative 2. So writing this whole equation, this is your answer. This should be your answer over here. So which one looks like that? C looks like the right answer over here. Yep, looks right. Perfect. The solutions to this equation are, okay, to do this, what I'm going to do is I'm going to use my CAS again. So I'm going to write solve 2 cos, oops, all right, no, 2x minus pi on 3 plus 1 equal 0, comma x, and we get 2 of these general solutions. So let's write them down in over here. So x is equal to 6. Remember that n1 means like any real integer. So that, for example, we'll write it as n minus 1. Okay, no. I want to write it n. I'll just write it k. We want to make it look the same as the answer. So 6k minus 1 pi all over 6, and x is equal to 2k plus 1 pi all over 2. Okay, now to know which one of them is the answer, they don't all look like, they don't look similar. Like this one over here, it's not in any of those, like it doesn't look similar. So what we're going to do is to get the most simplest way is to shove some values in. For example, let's right now shove when k is equal to 0. Let's do that. So when k is equal to 0, what's going to happen is we'll get x negative pi on 6. And if we shove in here, it'll be pi on 2. So these should be your actual answers. So let's try to shove that into one of those equations. So let's see. If we say, all right, if we shove in these equations, let's say 0. Let's for the first one, 0. What's going to happen? It's going to be negative pi on 3. This will have negative pi on 3. Wrong. So what else? Let's say we shove in 1. So it'll be 6 minus 4. So we're saying 4 pi on 6, which will be 2 pi on 3. Nope. And what about we shove in, negative 1, maybe. So it'll be negative 6 minus 2, 6 pi minus 8 over 6. Okay, nope, does not look right. So looks like this one over here has no way of giving us the answer. So anything that has this, nope, does not give us any good answers. So let's take that out. All right, what about this one over here? Let's try this one. Let's say we shove in 0. If we shove in 0 in that, we'll get negative pi on 6. Is that one of our answers? Absolutely. What about over here? If we shove in 0, it'll give us pi 2 over 6, which is pi on 3. Nope, that is wrong. So we know that this over here is one of our solutions. So it can only be this, maybe. Let's try this one. So if we shove in 0 to the second equation, we'll get pi 3 all over 6, which is 2 pi. So it gives us the same answer. So D should be your answer. Yep, that's how you would do that question. The graph of the function this, where D is your maximal domain, has asymptotes at where? So to find your x asymptote, what we're going to do is we're just going to solve the denominator. So 5 minus x equals 0. Therefore, 5 equals x. So x equals 5. Okay, x equals 5. Okay, this one's wrong, wrong, wrong. Now, to find your y asymptote, what we're going to do is we're going to go on our calculator right over here, and we're going to write expand. And we're going to write the whole equation. So 3x plus 2, 5 minus x, comma x. And this is our expanded form. Now, right over here, this is your y asymptote, your actual y. So y equals negative 3. Which one has y equals negative 3? E is your answer. Part of the graph of y equals f dash of x is shown. The corresponding part of the graph of f of x, so your original function. So what we know is that your original function f of x, its stationary points become the x-axis for your f dash of x. So let's look at the x-axis over here. We only have 2. It means at these part over here, these 2 parts, they should be stationary points in the real graph. So let's look over here. Nope. This one has over here, but also here. Nope, this one's not right. What about this one? Here and here. True. Let's just put a tick on that. Let's double check them. Nope, not this one over here. This one over here, this, nope. And this one over here and over here, nope. So only answer would be B. If f of x is this, where g is a differentiable function, then f dash of x is what? Okay, so let's write the equation. F of x equals e g x squared. Okay, now normally when we find the derivative of a exponential, we try to find the derivative of this upper function over on top of it. So what's that upper function? So your derivative would be, like this is how we write it, f dash of x is this upper function. The derivative would be the inside function 2x g dash x squared, and right to original function, so gx squared. So which one looks like this? 2x g dash x squared e gx squared looks like C is your answer. Is that true? Yep, looks right. Perfect. Items are packed in boxes of 25, and the mean number of defective items per box is 1.4. Assuming that the probability of an item being defective is binomially distributed, find the probability that a box contains, so we want the probability that a box contains more than 3 defective effects. So let's say x is equal or greater to 3. The probability that a box contains more than 3. More, okay, no, just, yeah, greater, not equal. More than 3. Defective items, okay, which we can rewrite this whole thing as just a probability as x is greater or equal to 4. Okay, Now, we know our n value, which is 25, but we don't know our p value. But here they give us the mean, and we know that the mean is written as this. Your expected value of x is np. Now, we know our expected value is 1.4, and our n value is 25, so we can find the p value. So, just go over here and just say 1.4 divided by 25 gives us 0.056. 0.056. Now we have n and p, so this is now easy. So let's go on our calculator and go menu. I'm just going to copy this over here. Okay, so go on menu, go on probability distributions, and go on binomial CDF. Yep, so your number of trials is 25, probability of success is this, and your lower bound is 4 to 25. Okay, and we get this over here, 0.048. Which one's that? B is your answer. If 4 to 8 f of x is equal to 5, then 0 to 2, this is equal to what? So, let's just maybe see if we can, like, let's for example draw. Let's say this is 4, and let's say this is 8. This is, like, let's say this is an actual graph, and this area over here is 5. Yep, so just that area over there is 5, because it's positive. And we've done some transformations. So we've dilated it by a factor of a half parallel to the x-axis. So what we're going to do is we're going to halve all the x values. So how did that look? We just halve these x values over here. So the graph will look like, so this will be 2, and this over here will be 4. So it'll look like, it'll look the same, but with just more dilated. So it's going to be more like a different kind of curve. But yeah, it looks like 2 to 4. So yep. So what will happen to the area? We kind of have to half, because we've dilated by a factor of, half. We have to, pretty much this area over here becomes 5 over 2. So it kind of, what happens is, it becomes more like this is how it looks like. It becomes more like that. So that will be 5 over 2 now. And what's happened is that it's also translated at -2 units to the left. So let's translate this graph over here. So it'll be 0. And this over here will now be 2. But the area is still the same. It's still 5 over 2. So so from 0 to 2 is equal to 5 on 2. So E is your answer. Given that log n plus 1 equals x, for values of n for which x is a positive integer is. Okay, so we have a log 2n plus 1 equals x, which is just 2x n plus 1. Your n to x minus 1. And okay, and let's say that x we make a k, so 2k minus 1, and we push all positive integers into it. Like for example, all of these have positive integers, so let's say we put 1, it'll be 2 minus 1, it results in a positive integer. Good. Okay, perfect. Wait, because our k value is equal to x. That's what we just said right over here. So it means, because what we're doing right now, what we're doing right now is we're shoving k's all positive integers, and that's what our x values will be, which means that our values of x for it to be a positive integer would be, it's this over here. Is that right? 2k minus 1. Is it B? N equals 2k negative 1. Yeah, looks right. Alright, the lengths of a plastic pipe that are cut by a particular machine are normally distributed over a random variable with a mean of this. Z is a standard normal distribution. If the probability of x is less than 259 equals this, then the standard deviation of the length of the plastic pipe in millimeters is what? Okay, I'm just really going to look at this like this. Okay, let's say, like this. Let's just draw a graph. And so this is your mean. Let's say this is your mean, like this is 0. let's say this is your normal distribution. And we know, actually, wait, let's just make it more, so let's take this would be, make it smaller, and push it like this. Okay, so let's say the first, there's 2. So let's say this is 0, and this is 259, because that, not 259, 250 actually, 250, because that's your mean. Okay, we know x is less than 259, so means that, let's say this 259 is over here, 259, and when x is less than it, so this over here, this area over here, is less than 259, it's equal to this. So let's say that was our normal distribution, our red graph. Let's just put this as a nice red, and let's put it at 0, and okay. And our normal distribution is like saying that it's great. So probably z is greater than 1.5. So let's say 1.5 is right over here. 1.5 is over here. This is 1.5. And it's 1 minus it. So it's pretty much this. It's the same as this. Okay. And we just want to find the standard deviation of the length. So to do that, at least now we know that the probability of, let's make this back to like the normal distribution. So it'll be z less than 259 minus your mean, which is 250, all over your standard deviation, yeah, is actually equal, so I'm just going to move this graph. Now it's actually move this graph over here, and it's equal to your 1 minus your probability of z is greater than 1.5. Now let's just try to find this. This is very easy to find. So if you go on your calculator and go on menu, probability, distributions, and we can go to normal CDF and say your lower bound's 1.5, your upper bound's to infinity. We put infinity. Your mean value is, because it's a standard deviation, it's the normal distribution, which means that it has a mean of 0 and the standard deviation 1. Okay, and we get this ugly value over here. So let's write that. No, we don't actually do that first. We have 1 minus the answer. Okay, so we want this over here. So wait. What do I do? This is what I need. Okay, this is what I need. Okay, let's write it over here. So probability of z less than 259 minus 250 all over 0.9331. So what we're going to do now is really look at it like this. Think of it, okay. So that value over here is pretty much right over here. That's your probability, that probability over there. So we can say, if we go on menu, probability, distributions, and we go to inverse norm, okay, and we can say your area is 0.9331. Yep. Actually, let's copy this, just copy that. Better be safe than, yep. Inverse norm, that's your area, and that's your mean, and your standard deviation, because it's a normal distribution. Okay. Oh, what just happened? Probability, distribution, inverse norm. That's your area. Okay, and we get 1.5. So it means that this value over here, so 1.5 is equal to it. 259 minus 250 all over theta. Oh, all over theta. So that's very easy. So it's just your theta, your actual, this thing over here, your standard deviation is 9 over 1.5, which is 6. So C is your answer for that one. Okay, that's not a bad question. It's very nice, actually. So, oops. Okay. And it's 6. So just put it over here. Just move these all over. Make it small. Put it over here. Nice. Question 12 says, alright, let me change the color. A clock has a minute hand 10 centimeters long. Okay, so this is your minute hand. Right. Let me just do one color so you can see it. So this is your minute hand. Just your minute hand. And a clock face with a radius of 1.15 centimeters is shown. So, yep. So this is your clock. Okay. So this is the tip of the pen, this is your H centimeters, and base of the clock face. Okay, so at 12 noon, both hands of the clock point vertically upwards. Okay, makes sense. So this over here, this is how it looks. So let's say this is your long hand, this is your long hand, and they both point upwards, these two hands. Yep, they both point upwards at 12 noon. So, and it's telling us both hands of the clock point vertically upwards and the tip of the hand is at maximum. Okay, so we know that the minute hand is at its maximum distance above the base of the clock. So this is your base. And it's, oh, sorry, that's not your base. This is your base. This is over here. This is your base. This is right over here is your base. So it's at its maximum. So it means here, when it's over here, it's at its maximum, and here should be it's at its minimum. The height H centimeters of the tip of the minute hand above the clock. So the height centimeters of the tip of the hand above the base of the clock T minutes after 12 noon. So let's say they both started at here and they started moving. So that's your initial, is given by, okay. So what do we know? Well, first, let's really look at it like this. If I draw, so because we start at its maximum, remember, we start at max. Think about which one would be, sine or cos? So it's sine. You really look at sine. Sine starts at like at its, oh, what am I doing? Okay. Like sine doesn't start at its maximum. You can see it doesn't start at its maximum. Whereas cosine over here starts at its maximum over here. So it has to be a cosine graph. Oh, done. These are all wrong. So we know it has to be a cosine graph. And what's the difference? So these are 15, 10. They all have the same. But the periods are different. So let's look at the periods. Because it's a minute hand. How much does the minute hand go around? Well, it goes around 60 minutes. So we can say that it goes through 60. It's 2 pi on n. So 2 pi 60 n. So pi on 30. So it should be pi on 30 as your value of n. So it should be E. Nice. This is not too bad. Okay, question 3. The transformation that maps, just think of maps as transforms the graph of this onto the graph of this is what? Okay, let's look at the answers. Okay, so we can see that these are all different. You can see that these are bracketed, whereas these are squared. Okay, it means the bracket ones you have to actually like multiply them. So it means that you have to multiply this by that and multiply this by that. Multiply this by that and multiply this by that. So let's try the first. Okay, let's try the first one. Let's try this first one over here. So it means that x dash is equal to half x minus 2. Because, yep, half x minus 2. And your y dash is y plus 0, just y. So now we know this. Let's shove it into this equation over here. So y dash is equal to cos half x minus 2. Oh, no, what am I doing? Oh my god, wait, I'm sorry, oh my god, what am I doing? Okay, first I need to actually transform this graph over here to the x, like, okay, so it'll be x plus 2 all over 2 for x, and this is what we sub in. So, y dash is equal to cos x dash plus 2 all over 2. Equals, that's it. So, what else? Okay. So put that there and Okay, no. What am I done? What have I done? Am I so tired? Why? Wait. I've done this wrong. So, x dash plus 2, then we're not dividing by 2, but it's multiply all by 2 to get your x. So it'll be 2x plus 4 equals x. Wow. I'm so tired today. Oh my god. Okay, so your y is cos 2x plus 4 equals. Okay. Does it look the same? Y equals cos 2x plus 4. Yep. Also, A should be your answer. Yeah, A should be your answer. Wow. I just want to double check the other ones because I think I may have done it wrong. That's why. I don't know. Okay, this A should be your answer because it looks the same. But let's try the other ones. This one's easy because it's just square and it doesn't have any brackets, so it's just half x minus 4 is your y dash. So, oh, what am I doing? So it would be x dash y dash is equal to just y. So if we solve that into equation, we transform this first. Well, transform this equation over here. So it'll be x dash plus 8. And we shove this, nope. It's a plus 8, not plus 4, so that's wrong. This one over here has brackets, so we're saying half x minus 1. And no, just 1. Wrong, absolutely. This one over here, wrong, straight away. And this one wrong, so yeah, it's just A. Alright. The random variable x is normally distributed. So actually, like this one still yeah. Question 14. The random variable x is normally distributed. The mean of x. So your expected value of x is twice the standard deviation. So twice your standard deviation of x. Then the probability of this is equal to when the standard deviation is closest to what? Okay. So, okay, so let me just make it into like the normal distribution. So like probability, let's change it to the normal. So probability of z greater than 5.2 minus your mean value. Now, we know we want to make it to this. We know our mean value is just 2 omega, so 2 standard deviations over the standard deviation is greater than 0.9. So now if you look at this graph like here, and that's 0, say, and this is some value here, and we know that when it's greater than it, this is 0.9. So to get this, it's 1 minus 0.9, which is 0.1. So there. So it should be 1. Wait, what am I doing? Okay, wait. Let's really look at this. Oh, so tired. Oh my god. I don't know. Yeah. Okay, so really look at this. So if we draw a normal distribution, 0. And we're saying, say it was over here. This is our value. And we know that because it's greater, this is 0.9. And what we want to do is we want to find this value over here. If we try to find this, makes our life much easier. So to get that, it's, okay, this will be 0.1. Let's change to 0.1. And we want to say the probability of z less than 5.2 minus 2 theta, all over theta. Okay, that's it. Wow, I don't know what just happened to me here. So now we just use go on our calculator and go menu, probability, distributions, inverse norm, and our area now is 0.1. And it's a normal distribution, luckily, so, and we get this ugly value. So now we put this over here and we want to equal it to 5.2 minus 2, your standard deviation, we'll just write it O, all over O. And we want to solve this answer for O. Gives us 7.23, 7.2, so let's say 7.23 something. So A is your answer. Alright, question 15. Part of the graph of the function f where a is greater than 0 is shown. Okay, the average value of the function f over the interval from negative 2a to a. So from here to here. So we know that the average value is what? Like it's 1 over this minus that. So a minus negative 2a integral the area of from negative 2a to a of the function f of x dx. That's what our average value is. So this will just change to 3a. So what's this? From negative 2a to a. Okay. They don't even give us the function, so what can we do? Okay, this area over here, right over here, is the same as this area over here. So they'll cancel out to be 0. So we don't even need to worry about those over here. Is there anything else we can cancel out? This area over here, does it cancel out with this one? Nope. They don't look the same. Well, actually, this area over here cancels out with this area over here. And we only get that, and we just need to find that value over here. Nah, it doesn't work like that. Okay, let's try this. So, we know 2 points. Let's try to find the equation for it, actually. So, let's do this. So, we know the point here and the point here. Let's use that point to find a gradient. So, negative a minus 2a from 0 minus negative 2a. So, that'll be negative 3a, 2a. So, it'll be negative 3 over 2. That's your actual gradient. And we know a point, so let's try to use this point. So, it'll be 1 plus a, negative 3 over 2, x minus 0. So y equals negative 3 over 2x minus a. Okay, so that's your equation. And this just, so from negative 2a to 0, negative 3 over 2x minus a dx. Let's find that. So, so when I calculate, go on shift plus and go negative 2a, 0. Okay, negative 3 over 2a. So this one's supposed to be 2. So x minus a. Yep. Dx gives us a squared. Okay, so now we know that multiplied by a squared, these two a's cancel out, so it'll be a over 3. Anyone has a? B is your answer for that one. Okay. A right angled triangle OBC is formed with the horizontal axis, and the point this, which is this one over here, where m must be 0 to 3, and a parabola 9 minus x squared is shown. The maximum area of the triangle OBC is what? Okay, let's just try to find the area of the triangle. So area is what? Well, it's here to here. This distance over here is m. So we know it's half m. What's your height? Well, our height is 9 minus m squared. Now we know this. Let's just, so it's m over 2, 9 minus m squared. Area, 9m over 2 minus m to the power 3 over 2. Okay, now let's find a dash. So it will be just 9 over 2 minus 3 over 2 m squared. And we want to let this equal to 0. So I'm going to do this in a calculator, much easier. So solve 9 over 2 equal minus 3 over 2 m squared equals 0, comma m. And we get m equals negative root 3 and m equals this. Okay, so m is root 3 and m is negative root 3, which, okay, m cannot be negative root 3 because m over here is all positive. We can see it's positive, so we decline this one, so it just must be this one. So now we know this over here. Let's just shove it back into the equation as area equation. So it'll be a equals root 3 over 2, 9 minus 3. Okay, 6 root 3 over 2, 3 root 3. These answer. Okay, that's not bad. Did I try to trick you? Did I try and trick us here? Okay, let me just draw this graph over here, just to double check. Was that our maximum area? So we have asymptote, we have a intercept here, and here, and here. And is it negative? Yes, so it's going to start like this, like that, and like that. Our maximum area, yes, it is the positive one. So yeah, that's not too bad. Question 17, let f of x equal this. A tangent to the graph of f. So we have a tangent to the graph of f. So let's just draw this because it's so confusing. I can straight away see this confusion. It's just getting... Okay, so let's just draw this graph. Well, it has a -2 at -2. And it goes like this. A tangent to the graph of f has a vertical axis intercept at this. Vertical axis means just your y-intercept. Yes, your y-intercept. So it has a vertical, so that, okay, find a maximum value of c. Okay, so, okay, wait. A tangent to graph has a vertical axis at 0, 3. Yep, so, and we want the maximum value of c. Okay, so let's say our tangent's over here. It gives us the lowest. What about if we start increasing it? So we get over here. We're getting better. Oh, okay, that's not a tangent. This is a tangent like this. Something like this. Something like that. Yeah. Okay, so we're getting closer. What about, let's say over here? Nope. Gets more lower. We want the maximum means the highest number, and the highest number means we want it to be like over here. Like we want it to be up. What else can we try? What about over here is just gotten worse. What about over here? So it's getting closer. So if it's at your x, let's say it's at your y-intercept. Yeah. If it's at your y-intercept, it should be your maximum value because that's the only, like, this is the most closest it can get to the, whereas if you just go over here then, it just gets then over here, which, yeah. So your maximum c value is your actual y-intercept. So we can say f of 0, negative log e 2. That's your, c is your answer for that one. Not too bad. Let a be from 0 to infinity, so it's a positive number, and b is an element or rails. Okay. Consider the function this. H from negative a to 0. Okay. This. So this is a hyperbola. A range of h of what? Okay, so, well, I know that x at x equals 0, it's going to have an asymptote. So here, x equals 0 is going to have an asymptote. And at b, but we know b is, it's an element of oral, so it could be negative or positive. So we need to be careful with that one. But we know a is positive, so the graph will look like this. Let's say b's here. Let's just say b is over here. Let's say b, y equals b. Yeah? And so we know the graph looks like this. Something like that. Okay. So, and we have a domain actually. So, the domain, because it's a positive, it's negative some, so it's some here. So let's just make some endpoints of here, and let's say just over here. So that's a, and that's negative a. Let's rub this nicely out. These are your endpoints. Anything else? So, yep, so let's see. Negative a to 0, perfect, from 0 to this. Okay. The range of h is, well, your range is from negative infinity to negative a inclusive union. Oh, no, what? That's your actual, yuck. Okay. It's from negative infinity to, we know this is your x intercept, so we need to sub in negative a into the function. So a, negative a plus b, negative 1 plus b. So negative 1 plus b inclusive union. And when was it a? So a over a plus b. So it'd be 1 plus b to infinity. which is D. Negative infinity, negative 1 over B. So negative, plus B. Perfect. Shown below is a graph of P, which is a probability function for a number of times X that a 6 is rolled on a fair 6-sided die for 20 trials. Let Q be the probability function for the number of times that X6 is not rolled. So it's actually the opposite. So we know that, say, okay, so this is how the graph of the opposite will look like normally. So because we have like this nice P of X, it will be just, these points will be all 0 then. These points will all be 0, and then this, it'll look like something like that. It'll look like a graph like that. Because we want 6 is not rolled. It's not on the 6 data in 20 trials, so Q of W is what? Well, and so Q of W is given by what? And we have these over here. So we know how Q of W will look like. It will look like something like this. Whereas this will be 0. So it will look like something like this, yeah. On here, they've given us that P's been let's look at the first one. P's it's first reflected along the pretty much y-axis. So it's going to be like, this point will look like, it'll look like this over here. It'll go like this. And then, so it'll look like this. And then they've translated it 20 units forward. So let's say, 20 units forward. So we're saying from, let's say it was here, it'll be 10, and over here. Okay, still looks the same, so that's good. It looks like the thing that we drawn. That's all right. It could be that. Let's try the other ones. The next one is just saying that, oh, what's this? Okay, so we can see that it's been dilated by a factor of 20. So first it's reflected. Again, it's reflected, so like that. It's also dilated by a factor of 20. So your X values become bigger. So the graph will look look like something like, I think like this. It will look like something very big. And then it's been translated, so 1 minus W over 20 equals 0. It's been translated 20 units to the right. So let's take this. Oh yeah, what's happening? Okay, so let's take this whole graph, and let's say we were translating it 20 units to the right. So okay, so it's here. 20 units to the right means here. No. That dilation has messed the graph up anyway. And this one, absolutely not. P equals 20, so translate this graph 20 units to the right. Nope, it needs to be reflected. And 1 minus P, absolutely not. So A should be your answer for that one. That's actually not bad, this whole question. It's just a translation question. Okay. Question 20. Let F all reals to be reals. F of X cos A of X. So it's cos of AX, where A is between all reals, okay. Be a function of the property this. F of X equals Fx plus H. For all H is an integer. It means so what it means pretty much, it means our period is an integer value too. So it'll be like 1, 2, -1, 2, 0. It's just a whole number. That's what actually this whole thing means. This property. And it says D, so g of x is log 2 f of x, be a function where the range of g is from -1 to 0. A possible interval for the domain is what? Okay, so we know this over here has a range of what? So it's log 2 f of x is between 0 and -1. And, okay. And we're going to try to get f of x. So this will be 2 -1 f of x, 2 to the power 0. So half f of x, half 1. So this is where f of x, to find, so for this f of x right over here, which is cos of a of x. This is where we want the range to be. It must be from 1 to half to 1, and we want to find the x value for that domain. Because we know the period must be a whole number. So our a value, because we know our period must be a whole number, so let's say 2 pi over n equals 1. So 2 pi, let's say, equals n. So let's say, okay, half cos 2 pi x is this over here. So this is just graph it. So go on a calculator and go on graphing and go write cos 2 pi times x. Yep, and this is how the graph looks. Okay, let me zoom in. Actually, no, don't even graph it. Go on this and just, I think what we can do is, we can solve it. Like, we can solve for x, which will give us our domain. So if we solve, can we do that? So let's try it. So 0.5 is between cos 2 pi times x. It's between 1, comma x. And it gives us these two general solutions. Okay. With these general solutions, let's write, okay, with these two general solutions, let's try to sub in like as n equals 0 first, and see if it's one of those answers, close, yeah. So let's say n equals, let's just write it as n first, so just n, and we get this. So our first we want to write is n equals 0. N equals 0, and we can negative 1 over 6 to 1 over 6. Nope. 5 over 6 to 7 over 6. 5 over 6 to 7 over 6. So 0.833 to this. So 7 over 6 is here. And this is close to it. It's likely B. We can maybe say, we'll leave it as B. We'll leave it there. Let's try other facts. So negative 1. Let's try negative 1 now. Negative 7 over 6. Okay, there's nothing that has two negatives. So, okay, so if we put like, let's say we put negative 2. It's just giving us both negatives, so, which is wrong. So it should only be, well, we can only have this like positive n. So n equals this. Which is 2. No. So B is the most closest, because what if we increase our n value to the positive, and if we increase it 4, 5, 6, what we're getting is more bigger numbers, and these are just 0.04 to some small numbers, and this one's that small to some number, you know. So B can only be your answer for that one. I'll be honest, yeah, it's a hard question. It really is, but knowing how to use your CAS to your advantage can really help you with this one. Yeah, so I hope you guys enjoyed this video. I hope you learned something, and yeah, make sure to like and subscribe to this channel. I'll be making more videos, and yeah, if you guys want private tutoring, I do private tutoring also. You can email me through this email right over here, or you can just go to my description and you'll find my email, and you can email me and we can have a discussion. Yeah guys, I hope you guys enjoyed this video, and please make sure to like and subscribe, and yeah, see you in the next video. Have a good day.